In this video, we will talk about multi-spanning tree protocol. Multi-spanning tree protocol (MSTP) is an enhancement of the traditional spanning tree protocol designed to improve the network efficiency and load balancing in VLAN environment. So MSTP, guys, allows multiple spanning trees to be created and managed within a single network and provides better use of redundant paths and improved network performance. So normally in the screen, as you are seeing, we have three different switches, and switch 1, 2 or 3 may become a root bridge in a 3-switch topology like this. And according to these three different scenarios, the ports on the switches will have different roles. If we were to have 100 different VLANs, it would be necessary to calculate these individually for each VLAN, since the result will always be the same and the control plane will have an unnecessary heavy load. So with the multi-spanning tree protocol, we are removing this handicap and we are reaching a more effective structure on the network. One of the biggest advantages of MST is VLAN load balancing, guys. So let's consider a topology consists of 2 links and 1000 VLANs as shown in the screen. Okay, so while you are making 1000 spanning tree calculations in classic spanning tree protocol for a topology like this, but in MST 1000 VLANs are mapped to 2 MST instances and you just get rid of unnecessary calculations. So this architecture provides multiple routing paths for data traffic and enables load balancing. So MST converges the network much faster than older versions like RSTP, PVST and the STP. In multi-spanning tree protocol, we have something called MST region. That is a logical grouping of switches that share the same MST configuration. So each MST region consists of switches that use the same MST configuration name, revision number, and VLAN to instance mappings. So this grouping ensures that all switches within the same MST region have a consistent view of the spanning tree and can efficiently manage VLAN traffic. So details are not shared between different MST regions, and different regions can see each other as virtual bridges. So one of these regions is used for inter-region communication, and that is called a regional root bridge. In multi-spanning tree protocol, guys, spanning tree instances are a key concept that enables the protocol to handle multiple VLANs efficiently by creating multiple spanning trees. Okay, so each spanning tree instance manages its own separate spanning tree for a subset of VLANs. So MST supports multiple instances. Instance 0 is used to move all internal information about spanning tree. So what I'm trying to say in here is, like, in an MST topology like this, for example, I have 4 different switches, right? For instance 1, and instance 1 is covering the VLANs 10 and 30, the root bridge is the switch 1. On the other hand, for instance 2, which covers the VLANs 20 and 40, the root bridge is switch 2. So I can end up with multiple root bridges for different MST instances. And we have something called MST revision number. So the revision number is used to indicate the version of the MST configuration. So it helps ensure that all switches within an MST region are using the same configuration and can detect changes in the configuration. So the MST revision number provides a way to track changes to the MST region. The revision number is not automatically incremented each time you make changes to the MST configuration, guys. This is very important. So each time you make changes, you need to increment the revision number one by one manually. And we have the MST Extended System ID. That is an extension to the traditional STP used in MSTP. So it helps uniquely identify switches and ports in a network, particularly when dealing with multiple VLANs and MST instances. So the Extended System ID is used to ensure that each switch and port can be uniquely identified within a network, especially when multiple spanning tree instances are in use. So it helps avoid conflicts and ambiguities in spanning tree calculations by incorporating additional identifying information. So how should I configure the MST? First of all, you need to go ahead and change the spanning tree mode to MST. Okay, spanning tree mode MST. In the second step, you need to define MST configuration. Okay, so you need to define the things including the MST region name and the revision number. So the MST region name and the revision number must be consistent across all switches in the MST region. That is very important. And this is how I am defining them. Spanning tree MST configuration, region name, and the revision number. So in the next step, you need to map VLANs to specific MST instances. So each MST instance corresponds to a spanning tree instance. So this is how I am doing the mapping. So for example, instance 1 covers the VLAN range between 1 and 99, and the instance 2 covers the VLAN range between 100 and 199. Okay? And lastly, guys, you need to define priority values for each instance. So this command helps the switch to be the primary root bridge for the specified MST instance. So switch with the lowest priority value will be the root bridge for that particular instance. So this is how I am going ahead and defining my priority values. For example, I typed spanning tree MST1 priority 8000 something, and I typed spanning tree MST2 priority 4000 something. And let's have a look to the other configurations in other switches. Okay, in here for ACC1 and ACC2, I don't see any priority configuration, which means those guys will go ahead and use the default spanning tree priority value, which is 32,768. If you can read, of course, I'm very much sorry. But in this one switch, I see there are some priority configurations made. For example, for spanning tree MST2, the priority set to 8000 for this switch. And for the MST01, the priority set to 4000 for this switch. Okay. For instance 2, priority is 8000 for this one, but for instance 2, priority is 4000 for this one, and vice versa for MST01 instance. So in this example, in summary, story short, this two switch will become the root bridge for instance 2, which covers VLAN 100 and 199 because it has the lower priority for this range. And this one switch will become the root bridge for instance 1, which covers a VLAN range between 1 and 99 because the priority is 4000. This one has a priority of 8000 for this, and the others are using the default priority, which is 32,000 something like. So if you want to configure a switch as the primary root bridge for a particular MST instance, we have this command. Okay, for example, spanning tree MST1 root primary, it will force this switch one to be the primary switch, the root bridge for the instance 1. And also we have another configuration, spanning tree MST2 this time, root secondary, and it will make this switch a secondary root bridge for the instance 2. Okay, and we have the path cost configuration as well. So for example, for that particular interface Ethernet 02, if I go ahead and configure spanning tree MST1 cost and a very high cost value, and then if I go ahead and type show spanning tree MST to verify the configuration, you will be able to see that this port will go to the alternate state, okay? Because port with a higher cost will be less preferred, and it means this port will be in blocked status. And to verify the configuration, we can use the show spanning tree MST1 or show spanning tree MST2. I mean, basically it is show spanning tree MST and the instance number. Okay, that is used to display information about MST instances. And this command provides details about the spanning tree status, including the root bridge, priority, and various statistics related to the particular MST instance. So for example, for MST1 instance, this Ethernet 02 is in blocked state. However, for MST2, for instance 2, this same interface is the root port and in forwarding state. So I hope it's very much clear, guys, and thank you so much for joining me in this section as well.